My dear grade 8 students, it's me again, Ma'am LORNZ of Pililla Integrated National High School. Welcome to my video tutorial on grade 8 mathematics lesson. Let's go!
Hello, my dear students. Today, I am going to discuss about operations on rational algebraic expressions. In this video tutorial, I will teach you how to add and subtract rational algebraic expressions with the same denominators, and add and subtract rational algebraic expressions with different denominators. To add or subtract fractions, you must always check the denominator. It can easily be done if the fractions are similar. Otherwise, you have to make a fraction similar by finding its equivalent fractions. Rules also apply to rational expressions, in which only similar terms of algebraic expressions can be added or subtracted. Rational algebraic expressions are similar if the terms have the same literal coefficients. Thus, A over B plus C over B equals A plus C. So therefore, you add the numerators over the common denominators, or A over B minus C over B is equal to A minus C over B. Thus, we subtract the numerators over the common denominator. Let us have our first example. Add or subtract the following. 4 over 9 plus 5 over 9 equals. So the first thing that you're going to do is to add the numerators. So our denominators are 4 and 5. And you keep the common denominator, which is 9. Add the numerators and again keep the common denominator. And adding 4 and 5 is 4 plus 5 over 9, which is equal to 9 over 9, or in lowest term, 9 over 9 is equal to 1. So this is the lowest term of 9 over 9, 1. So your answer or final answer is 1. Our next example is 5 over 9 minus 1 over 27. You will notice that we have different denominators. So this is the similar fraction or expression. So if this is the case, you need to find the LCD of the denominators 9 and 27. And the LCD is 27. Using fundamental property, we have now 27 divided by 9 is 3 times 5. 27 divided by 27 is 1 times 1. Simplifying further, we have 3 times 5 is 15. 1 times 1 is 1. Subtract the numerators and keep the common denominator. And subtracting 15 minus 1, you have 14 over 27. So this is now your final answer, since there is no common factor between numerator and denominator. Now, for our next example, we have 4m over 9 plus 5n over 9. Now, the given is a similar rational algebraic expression. So, we're going to add the numerators 4m and 5n. So So 4m plus 5n are dissimilar terms. So you can't add 4m and 5n. So, but you have to express this as 4m plus 5n all over the common denominator 9. Okay, so that is, we add the numerators, then we keep the common denominator. Now, the next example is 3 over PQ minus 9 over PQ. So, subtract the numerators and keep the common denominator. And subtracting the numerators, we have 3 minus 9 over PQ. Then simplifying further, we have negative 6 over PQ. Moving on to our third example, K over K squared minus M squared minus M over K squared minus M squared. Again, the given expressions are similar. So we have to subtract the numerators and keep the common denominator. Okay, and that is K minus M over K squared minus M squared. Now we need to factor the denominator. And factoring the denominator, we have K minus M times K plus M. Simplify or find the lowest terms. We have now 1 over K plus M because we cancel K minus M, which is the same as 1 times K minus M over K plus M. So cancel them. The answer is 1 over K plus M. Our next example is 5 over x squared plus 2x minus 15 plus x over x squared plus 2x minus 15. Of course, we need to find or add the numerators. And adding the numerators, we have 5 plus x. Factor the denominator. And factoring the denominator, we have x minus 3 times the quantity of x plus 5. And simplifying further, we have, by cancellation, we have 1 over x minus 3. How are you going to find the least common denominator or LCD of rational algebraic expressions? In step 1, you factor its denominator completely. List all different factors other than 1 that appears in any of the denominators. When the same factor appears in more than one denominator, write the factor with the highest factor that appears. Step 3. The least common denominator is the product of all the factors listed in step 2. Let us have our next example. Assume that the given expressions are denominators of fractions. Find the LCD for each given set of expressions. 4x cubed y squared and 6x squared y to the 5th. Factor its denominator, and factoring, we have 2 times 2 times x cubed times y squared. Okay. Factoring 6x squared y to the 5th, 2 times 3 times x cubed times y squared times y cubed. Choose the factors with the greatest exponents, and the LCD is 2 times 2 times 3 times x cubed times y to the 5th. Multiplying the numerical coefficients, we have 2 times 2 times 3 is 12. And copying the exponents and the variables, we have x cubed and y to the 5th. Let us have another example. Assume that the given expressions are denominators of fractions. Find the LCD for each given set of expressions. C squared minus 3c minus 10 and c squared minus 8c plus 15. Factor the denominators, and that is, the first one is c minus 5 and c plus 2 for c squared minus 3c minus 10. And the second one is c minus 5 and c minus 3 for c squared minus 8c plus 15. Then, you have the LCD is divisible by both polynomials. Therefore, we have c minus 5, c plus 2, and c minus 3. This example is 7 over 3x plus 1 over 9x. The LCD of 3x and 9x is 9x. Therefore, we have, by fundamental property, 7 over 3x plus 1 over 9x is equal to 7 times 3 over 3x times 3 plus 1 over 9x. And multiplying 7 and 3, we have 21. Multiplying 3x times 3 is 9x plus 1 over 9x. Therefore, we have now, adding the numerators, we have 21 plus 1 is 22 over 9x. Moving on to our second example, we have 2 over d minus 3 over d minus 4. The LCD is d times the quantity of d minus 4. By fundamental property, we have 2 times d minus 4 over d times d minus 4 minus d minus 3 over d times the quantity of d minus 4. And distributive and commutative properties, we have 2d minus 8 and d times the quantity of d minus 4 minus 3d over d times d minus 4. By subtraction, you have 2d minus 8 minus 3d over d times the quantity of d minus 4. Combine like terms in the numerator, we have negative d minus 8 over d times d minus 4. Let us try another example. Find the sum of 4n over n minus 1 and 1 over n plus 4. The LCD of n minus 1 and n plus 4 is quantity of n minus 1 times the quantity of n plus 4. 4n over n minus 1 plus 1 over n plus 4. Using the fundamental property, we have 4 times n plus 4 over n minus 1. N plus 4 plus 1 times n minus 1 over n minus 1 times the quantity of n plus 4. Add the numerators, and adding the numerators, we have 4 times n plus 4 plus 1 times n minus 1 over n minus 1 n plus 4. Using distributive property, we have now 4n plus 16 plus n minus 1 over n minus 1 times n plus 4. Combined terms in the numerator, we have now 5n plus 15 over the quantity of n minus 1 n plus 4, and that is the final answer. Our next example is to find the difference between 2 over f minus 2 minus 9 over f plus 2. The LCD of f minus 2 and f plus 2 is f minus 2 f plus 2. By fundamental property, you have 2 times the quantity of f plus 2 over f minus 2 f plus 2 minus 9 times the quantity of f minus 2 over f plus 2 divide or multiplied by f minus 2. And subtract the numerators, you have now 2 times the quantity of f plus 2 minus 9 times the quantity of f minus 2 over f minus 2 times f plus 2. Using distributive property, you have now 2 times f or 2f plus 4 minus 9f plus 18 over f minus 2f plus 2. Combining like terms in the numerator, we have now negative 7f plus 22 times the quantity of f minus 2f plus 2. In order to understand better the lesson, you need to remember the following concepts. Step 1. If the denominators are the same, add or subtract the numerators. Place the result over the common denominator. If the denominators are different, first find the least common denominator. Write all answers or rational expressions with this LCD, and then add or subtract the numerators. Place the result over the common denominator. And step 2, simplify. Write all answers in lowest term. Now that you know already how to add and subtract rational algebraic expressions, let us try some exercises. Number 1, you are asked to perform the operations being asked in each item. Number 1, find the sum of 3x over x minus 2 and x over x minus 2. The second one is find the sum of 4 over 5b and 2 over 5b. Number 3, find the difference when 3x minus 8 over x plus 7 is subtracted from 5x minus 1 over x plus 7. And number 4, find the answer when x over x minus y decreased by y over x minus 1. I'm giving you 3 minutes to answer the exercises. Let's try. Let's go. Time starts now. Okay, time is up. Okay, let us check your answers. Number 1 is 4x over x minus 2. Number 2 is 6 over 5b. 2x minus 7 over x plus 7 is the answer for number 3. And number 4 is x plus y over x minus y. Congratulations! Job well done! Moving on to our next set of exercises, we have, again, you are asked to perform the operation being asked in each item. Find the sum of 2 over 3x and 5 over 2x. Find the sum of 4 over 5b and 2 over 5b. Find the difference of 5 over x minus 7y over x plus 3. And find the answer when 7 over x plus 3 increased by 4x over x plus 6. Now, we have 3 minutes to answer these exercises. You have 3 minutes to answer the exercises. Starts now. Alright, time is up. Let us check your answer. Number 1 is 19 over 6x, 6 over 5b for number 2. Number 3 is 5x plus 15 minus 7xy over x times x plus 3. And the other one is the last number, 4x squared plus 19x plus 42 over x plus 3 times x plus 6. Congratulations, my dear students. Job well done. Now, before I end up my video tutorial, let me share to you these quotations. Math may not teach us how to add, love, or subtract hate, but it gives us hope that every problem has a solution. This is it, my dear students. Thank you very much for watching. I am giving my heartfelt thanks to the following: Mathematics Grade 8 504A Learners Material, Quarter 1, First Edition 2020, Copyright 2010, Pearson Education Incorporated, all right reserved.
Thank you for watching. Bye-bye.